Picture this: a stadium full of fans, each person rising and falling as they make a Mexican wave, creating a wave that seems to move around the entire arena. This is an example of a wave in action. But don't be fooled. Waves aren't just for sports fans. They're everywhere, from the light that travels from the sun to reach us, to the sound that travels from your speakers to your ears. Waves are disturbances that move through space and matter, transferring energy from one point to another without transferring matter. The wave at the stadium is a perfect example. Each person stands up, raises their hands, and sits down again, passing the energy along without physically moving from their spot. In the world of physics, we categorize waves into two major types: longitudinal and transverse waves. In longitudinal waves, such as sound waves, the disturbances or oscillations move in the same direction as the wave itself. Picture a slinky being stretched and compressed. The individual coils move back and forth along the direction of the wave, but the slinky as a whole doesn't move from its place. On the other hand, transverse waves, like light or the wave in the stadium, have oscillations that move at right angles to the direction of the wave. The energy is passed along, but the matter doesn't move from place to place. We like to be able to describe and compare waves. We need 4 key properties to do this: wavelength, frequency, amplitude, and time period. The wavelength is the distance between two similar points on the wave, such as from one peak to another. Frequency, measured in hertz, refers to the number of complete waves that pass a point in a given amount of time. Think of it as the number of buses that arrive at a bus stop every hour. The amplitude is the distance from the peak of the wave to its middle position. Finally, the time period is the time it takes for one complete wave or oscillation. So, next time you're enjoying the warmth of the sun or listening to your favorite tune, remember, waves are at work. They transfer energy and information from one place to another without moving matter. They can be longitudinal, like sound waves, or transverse, like light waves. And understanding their properties, wavelength, frequency, amplitude, and time period, can unlock a deeper understanding of the world around us.